I'm John Hendrick, Senior Technical Writer for Wallaroo. In this video, I'll be demonstrating how to use the Wallaroo SDK within a Google Vertex workbench to do things such as connect to a Wallaroo instance, upload a trained ML model, deploy the model, perform singular and batch inferences, one through the SDK and one through an API request. If this is your first time hearing about Wallaroo, welcome. Wallaroo is the last mile for your MLOps deployments. Wallaroo takes your ML models trained in platforms such as AWS SageMaker, Google Vertex, and other platforms and deploys them in production environments for inferences, model competition analysis, and other functions. In another video, we demonstrated how to install the Wallaroo SDK into a Google Vertex workbench. This time, we'll be connecting to a Wallaroo instance from within a Google Vertex workbench and working with a trained model. These instructions can be found on the Wallaroo documentation site at docs.wallaroo.ai, and a full tutorial is available with sample models and data from the Wallaroo's tutorial GitHub repository. We'll start out in a Google Vertex notebook with the Wallaroo SDK installed. We'll import the Wallaroo SDK library, then make our connection to our Wallaroo instance. For this to happen, we need to know our Wallaroo prefix and suffix for the URL. In this example, this means we're connecting to the server Squishy Wallaroo and launching the Wallaroo client. I didn't name it, folks. I just like it. Wallaroo supports multiple identity providers. Since we're already in a Google-based environment, I'll use that as my identity provider and select Google for my authentication method. Once I've confirmed I want to give this connection permissions into my Wallaroo instance, I can go back into my Google Vertex and work from there. With the connection established, I'll next set up my workspace. Workspaces in Wallaroo are used to segment models and pipelines into their own environments. I have some helper functions that will help set us up by either creating a new workspace or selecting one that's already been created by its name. Once we save the workspace to a variable, we use the setCurrentWorkspace method. This way, all the commands from this point on will use this workspace as our default. Now we create our pipeline. Pipelines are the deployment mechanisms for our models. A pipeline can specify one or more models in a series of steps, whether that's pre or post-processing to format data into a form that the model expects, or other needs. For our example, I'm using a pre-trained Aloha demonstration model used to detect whether a web name is authentic or fraudulent to prevent scammers from collecting information from people. I'll upload that model into my workspace via the upload model command, where I'll specify the name I'm giving this model, the file name I'm uploading it from, and then specify that this is a TensorFlow model. With the model uploaded, we can now tell our pipeline that this model will be a step inside this pipeline. We do that with the pipeline add model step method. We're keeping this nice and easy, just one model, one step. With that done, we now deploy the model. This can take anywhere from 15 to about 45 seconds as it allocates resources from the Wallaroo environment for this pipeline. Once this is complete, the pipeline will remain deployed until we undeploy it, and that will keep it available for any inferences we want to do the second we want to do them. Pipeline is deployed, now it's time for inferencing. There's a couple of ways we can run inferences. I'll run a quick sample check via a file. I'm going to feed a data frame of inference data into our pipeline with the SDK command infer from file and get back the results as a data frame. So we see, you do the inference, get the result. Now let's do a batch inference using an API request. In this case, 25,000 records submitted at once. This could be done through the SDK as well from our infer from file command, but for variety, we're going to do it through an API request. I'm going to display the pipeline's inference URL with the deployment URL command. And then I'm going to grab my security token using the mlops_dict command and extract the token from the result. Now that everything is ready, I'm going to submit my batch inference request using a curl command. This can be done with Python requests or any other method that supports API calls. Again, I'm going to submit all 25,000 records at once and wait for the results. And we're done. In this case, opening up the results file is actually going to take longer than submitting the inference in the first place. But we can see all the results right here we can parse through. Now, just for the sake of this demonstration, I'm going to undeploy the pipeline that returns the resources back to the Wallaroo instance. And that's our demonstration. Data scientists working within Google Vertex can train their models and then go right into deployment using their Wallaroo instance. They can start tracking, doing other tests, managing models against each other, and seeing the real results in real time. As mentioned earlier, this entire tutorial is available on the Wallaroo documentation site at docs.wallaroo.ai, and you can also find the complete tutorial with sample data and models on the Wallaroo tutorial GitHub repository page. If you're curious about using Wallaroo for yourself, you can register for a free license right now for Wallaroo Community at portal.wallaroo.community. Just put in information, you can deploy it right into your Kubernetes environment. I'm John Handrick, Senior Technical Writer for Wallaroo. Thank you for viewing, and welcome to Wallaroo.